Hello everyone, welcome to the channel Chemical Engineer. I am Sahil Yadav and in this video we are going to discuss about cooling towers. So in this video we are going to discuss about efficiency or effectiveness calculation of a cooling tower. So if you are new to the channel, please subscribe to the channel and let's start the video. Before going to directly to the formula, I would first talk about what is cooling tower and how it works. So all these marked red or blue colored thing is called as packing, or we call it as a fins, whatever you call. So they are responsible for the heat transfer. Okay, so what actually happens is, here we have a collection tank. This is a collection tank where we store a cold water or cooled water. This cooled water goes to the plant, gets hot and comes back to the top of a cooling tower. Here there are some nozzles through which this water is passed through this packing. Okay, so water will go down, and with the help of this impeller, what will we do is we will force out the air from this outside to this fins, and then this air will be carried away with this fan. So from here warm air will be going out, and from here cold air will go in, so they will do heat transfer. Okay, so in calculation of effectiveness formula we require this temperature of air. Okay, so the important is air temperature, second important parameter will be hot water temperature, and third will be cold water temperature. Okay, so let us go directly to the formula and let us see what it actually shows. All right, so in formula of effectiveness of a cooling tower, it is calculated as range divided by, in bracket, range plus approach. Okay, so range divided by range plus approach. By this we will be going to calculate cooling tower effectiveness. Now let us see what is range. So range is nothing but a difference between a water inlet temperature minus water outlet temperature. So in this video, in this slide, difference will be, suppose this is TH and suppose the outlet water temperature is TC, then range will be, what will be range? TH minus TC. Okay, this will be our range. And approach, in approach we have outlet cold water temperature minus ambient wet bulb temperature. I hope you know wet bulb temperature. So wet bulb temperature is a temperature of an air considering its humidity. Okay, so what we do is, how we calculate wet bulb temperature? So we use the thermometer which is wrapped with the wet muslin on the top, and with the help of adiabatic heat transfer it calculates the temperature. Rise in mercury is due to adiabatic heat transfer. So this is about wet bulb temperature. Maximum achievable temperature that we can achieve through cooling tower is known as wet bulb temperature. Okay, maximum that we can achieve is wet bulb temperature. So suppose we call it as a TW. So what will be approach? Our approach will be TC minus TW. Okay, so range divided by range plus approach will give you a effectiveness of a cooling tower. Now let us suppose within current examples of refineries or different places, what is a general cooling tower effectiveness? So it comes around 50 to 60% or less than that. If your cooling tower is working on a 50 to 60% effectiveness, then you can call it as a good working cooling tower. If it is below 50 degrees Celsius, then you should work on cleaning and other things that we will discuss in upcoming videos. In upcoming videos we are going to discuss about evaporation rate of a cooling tower, what are the losses of a cooling tower, what are the calculations that are done while designing a cooling tower, and types of cooling towers. All these things will be discussed in our upcoming videos. And so this is all about this video. I hope you liked it. So thank you for watching.